Hi, everyone. This is our project for Team Gravity Wells, a one-week data science course made up of our instructor, Ian, Jason, and me, Sureeta. We chose a data set from Kaggle showcasing key indicators of heart disease. And from this data set, we hypothesized that a person's daily habits and features strongly affects whether or not a person develops heart disease. And furthermore, to conduct machine learning, we stored categorical values and converted them to numerical representation.
So after we grabbed our data set from Kaggle, we converted it into Python as a CSV file, and we created some visualizations using the Plotly Express library. So the first visualization we created was this correlation heat map, and this allows us to pick out if there are any strong correlations between any of the variables in our data. And this was a good stepping stone to create other graphs, because after picking those correlations, we can look further into correlations between two specific variables to see if they were good indicators for heart disease. So the next thing we created was this histogram, which looked at the two variables on the chance of getting heart disease for people with or without difficulties walking. And we noticed that for the people with difficulty walking, they had around a 3.5 times greater chance of getting heart disease compared to those without any difficulty walking.
We also chose to use violin plots, and we decided to compare people with and without heart disease and in which age categories they are most evident in. And how this works is that the wider the plot on the x-axis, the more the occurrences of that variable on the y-axis. And you can see in the chart, most of the yeses occur near the 80 or above category. And so then we chose to compare the IQRs, and you can see that the no's have a greater distribution as opposed to the yeses, which happens mostly in the senior categories. And going on to the next violin plot, we chose to compare BMI to heart disease. And again, using the box plot, we found that the median and the IQR for people with and without heart disease is around the same. And these samples showed us that BMI alone is not a good indicator of heart disease.
The final visual we created was this Subverse chart, and we wanted to demonstrate the relationship between those who smoked, those who drank, those who did both, and those who did neither, with their chances of getting heart disease. So among these four groups, we found that those who only smoked, 12.8% had heart disease, and this was the highest occurrence of heart disease in all four groups. And the lowest actually was those who only drank, and they had a 3% chance of getting heart disease. So from this, we concluded that smoking and the chance of getting heart disease could be positively correlated. And actually, we found that drinking and the chance of getting heart disease could be negatively correlated. However, this result could be because we had a low sample size for those who only drank. And this actually goes against some medical studies which show that drinking could have adverse effects that increase your chance of having heart disease. One thing to point out is that there are certain groups, if you look at the border between the blue and the red in the chart, it's hard to see, but there's actually a group that has 251 people who have heart disease but only drink. And on the other side, between the blue and the red, there's also another smaller group who have heart disease and smoke and drink, just to point that out.
Next, we chose to do...
Sorry, I forgot to do this too. So next we created two machine learning models to predict our data for given any input. So first we used a support vector classifier, or an SVC, and this model uses SVMs, or support vector machines, in which a hyperplane is fit onto the data, which separates the training data into two groups to predict whether or not a person has heart disease or not. And the hyperplane separates them into yes heart disease and no heart disease. So using this model, it was able to make predictions. And as you can see, this SVC model has an accuracy of around 71%. And looking at the confusion matrix, we see that it is a relatively good model, as there aren't that many false positives or false negatives.
So next we chose to do a random forest classification. So how this works is that a random forest is made out of a bunch of decision trees, which are further made up of decision points, like branches, and we input a data point. It goes through a series of decisions, and the final one determines the final solution. And so what we decided to do with this is make a confusion matrix to test for the specific errors in the model were made. And we can see here that it has a pretty decent accuracy. And so in cessation, we hypothesized that one's habits, BMI, age, and other underlying health conditions are good indicators of one's chance of developing heart disease. And for example, from the histogram and sunburst, we could tell that difficulty walking and smoking could lead to or indicate heart disease. And we also interpreted from the correlation map and the violin plot that heart disease mostly is found in later stages of life. And with those finds, we also found factors that may not lead to heart disease, like BMI, according to our samples. And problems were encountered, like with the Subverse chart, it indicated that alcohol drinking led to decreased chances of developing heart disease, which could be disproved by previous research from scientists. And so we furthermore created machine learning models. The random forest models and linear single vector classifiers helped us to determine whether a person has heart disease, and the confusion matrix helped us to analyze the results. And through all of this, we discovered that most of our hypotheses were correct. And if not, found out that the outcome was not what we expected. And thank you for listening to our presentation.